Hey guys, let's go over this trig review number 2. So it says, what is the measure of angle B to the nearest degree? Let's zoom in just a smidge. Okay, so angle B is this angle up here at the top, and we need to find it, and we need to figure out which law we have to use. Let's see. If I find angle B, we have the opposite side, and we have another angle and its opposite side. We can use the law of sines. So we can go sine of angle B, because we don't know what it is, over its opposite side is a 10, equals the sine of another angle that we do know is 30 degrees, over its opposite side is a 7. And then what we do is we cross multiply. So sine of B times 7, we write that as just 7 sine of B, equals 10 times sine 30 is 10 sine 30. And we need to solve for B. So we need to get the sine of B isolated because this all goes together. You can't separate the B from the sine unless you do something mathematically. But I can move the 7. To do that, I have to divide both sides by 7 to get rid of that 7. And now I am allowed to get that B out of the sine. To get B out of the sine, I have to take a special kind of sine. I have to take a sine inverse. But it has to be of this whole thing, 10 sine 30 all over 7. So now it's calculator time. You need to make sure you're in degree mode in your calculator. So I have this calculator here, one of my favorites. I need second sine to get sine inverse. 10 sine 30 divided by 7, close parentheses, equals approximately to the nearest degree would be 46 degrees, which is letter B. All right, I have these new highlighters that I want to use. They're all Star Wars themed, so they're fun, but they're little babies. Okay, all right, so number 2, it says, what is the measure of angle G? So angle G is this angle that I need to find. And I do have its opposite side, and I have another angle that I know, but I do not have its opposite side. So I don't have enough information to use the law of sines on this one, but what I could do is I could find that opposite side right here. It's across from uppercase F, so I'm gonna call it lowercase f. I've got side angle side across from it, so I could use the law of cosines to find that side. And then after I find that side, I can use the law of sines like I did in number 1 to find angle G. So I need to find F first. So law of cosines will go F squared equals each of the other two sides squared and added together, minus 2 times each of them. It's law of cosines of the angle in the middle is a 61-degree angle. And then we need to clean that up. So I've got like a speck on my phone. All right, so to clean that up, we've got F squared equals 7 squared is 49, 14 squared is 196, so 196 plus 49 is 245. Because I can only add these two together. The other 3 numbers are next to each other. Next to means multiplication, so I need to multiply 2 times 7 times 14 all together. And I get 196 cosine 61. Okay, I can't do anything else. This 245 and this 196 are not like terms because that 196 is attached to a cosine. So the only other thing I can do from here is to undo the square by square rooting it. So F is going to be approximately whatever that is in the calculator. And let me grab a class calculator, because the one that I've been using is, I love it because the way you see it is how you type it in. You type in the square root of that whole thing, hit equals, bada bing, bada boom, you got your answer. On this one, I have to do it backwards. So I have to go 61 and then cosine. And then we have a negative 196 next to the cosine in front of it. So that means times 196, make it negative, hit equals. And then we've got this positive 245. So plus 245 equals, and then I have to take the square root. So you hit the square root button, and that's approximately to the nearest degree 12. or sorry, to the nearest whole number. Well, let's not go to the nearest whole number. Let's go to the nearest tenths, 12.2. Okay, so F is approximately 12.2 because that's the side, not an angle. It wasn't a degree, I misspoke. Okay, so now we found that side. Now I have enough information to use the law of sines to find angle G. So sine of angle G, because I don't know what it is, over its opposite side is 14, equals sine of 61. I do know that angle. Over its opposite side, we just found it, is 12.2. And then we cross multiply. So sine G times 12.2 is 12.2 sine G equals 14 times sine 61 is 14 sine 61. We need to solve for that angle G, so we're gonna need to get the sine of G isolated, so I'm gonna have to divide away the 12.2 on both sides. And now that the sine of G is isolated, I can get G by itself, but I have to take a special kind of sine for it to be released. So I need to take sine inverse, and just because I'm a little lazy, it's gonna be the sine inverse of all of that. It's gonna be plugged in there, okay? So if I'm using this calculator, I need to take care of this first. So 61 sine times 14 equals, then divided by 12.2 equals. And then I have to take the inverse sine. So second sine, oops, it didn't work on that one. So let me try this again. 14 sine 61 divided by 12.2 is this number. So if I take the second sine of that number, domain error. Oh, you know what? That's because I need to round this to more decimal places. What was that again? That was 61 cosine times 196, make it negative, plus 245 equals, and then hit the square root button. So let's go out 2 decimal places, so 12.25. I remember that was an issue before. So when you're not finished yet, at least go out 2 decimal places because it will affect the domain error in our calculator. So let's try this again. So 61 sine times 14 equals, divided by 12.25 equals, and now take the second sine, and now it works. So that's approximately to the nearest degree, 88 degrees. Isn't that funny how one little decimal place affects how we plug something in here? So here's the rule of thumb. When you're not finished with your final answer yet on a problem, but you have to get an answer before you get the final answer, go out at least 2 decimal places when you round, okay? Because if you round too much too soon, it's gonna say domain error, and we don't want that. So 88 degrees was the answer, so C is it. Get my little baby highlighter. I got him at Target, by the way. All right, number 3 says the sundial in Myra's garden is 11 feet from the bird bath. A flagpole is 8 feet from the bird bath. The angle formed at the bird bath is 37 degrees. A bumblebee flies from the sundial to the bird bath, to the flagpole, and back to the sundial. What is the shortest distance in feet that the bumblebee could have flown? So I see 3 things that this bumblebee is flying towards. He is going from a sundial to a flagpole to a bird bath. He's making a triangle. Okay? And it says the sundial in Myra's garden is 11 feet from the bird bath. So from the sundial to to the bird bath. Sundial to bird bath is 11 feet. A flagpole is 8 feet from the bird bath. So the flagpole to the bird bath is 8 feet. The angle formed at the bird bath is 37 degrees. So the bumblebee is flying around. So that means the bumblebee is going around the perimeter of that triangle. Perimeter is where you add up all the sides. So in order to add up all the sides, I need that third missing side, which we'll call it lowercase b because it's across from angle B. So to find that side, because I have side angle side across from it, I'm going to be using the law of cosines. So b squared is equal to each of the other two sides squared and added together, minus 2 times each, times the cosine of 37 degrees. And then we got to clean that up. 11 squared is 121, 8 squared is 64, 121 plus 64 is 185. So b squared equals 185 minus 2 times 11 is 22. 22 times 8 is 176. Cosine of 37 degrees. Okay, that's all I can do, and now I have to undo the radical by taking a square root, I have to undo the square by taking a square root. I misspoke again. So b is going to be approximately whatever that is in the calculator. So I'll do it in this one this time. So second square root, 185 minus 176 cosine 37 equals 6.66. So let's go, or 6.67. Remember, it's not our final answer, so let's at least go 2 decimal places. So b is approximately 6.67. So remember, the bumblebee's path is around the perimeter of that triangle. So P for perimeter. We have a side that is 6.67 plus a side that's 11 plus a side that's 8. Well, I know 11 plus 8 is 19. 19 plus 6.67 is 25.67. Oh, did I forget to mention? None of those were correct. So 25.67 feet, or approximately 26 feet if I were to round to the nearest whole number. Yeah, none of these were correct. All right. Number 4 says, what is the radian measure of the angle that subtends an arc of length 3 radians on a unit circle? All right, this one's giving us some clues. First of all, we're talking about an arc on a unit circle. Because it's a unit circle, I know the radius is 1 unit, okay? They gave me the arc length. Arc length, we use the letter S for. It's 3 radians, so I'm just gonna put 3 rad, okay? We need to find the angle. This is what we're trying to find. So at the beginning of this unit, we had an arc length formula. S equals theta times R. S is the arc length, theta is the angle in radians, and R is the radius. Well, we have the arc length, S, it's a 3, so I'm gonna plug it in. We don't know theta, so it's just theta, but we know the radius of a unit circle is a 1. Oh, well, theta times 1 is just theta, so that means that theta, the angle, must be 3 radians. So D was the answer. Page. Number 5 says a flag is made from a triangular piece of fabric. One angle of the triangle measures 61 degrees, and the sides of that meet at this angle have lengths of 5 inches and 16 inches. What is the area in square inches of the fabric? So we're using the area formula. The area formula for trig is area equals 1/2 times 2 of the sides times the sine of the angle in the middle. You need side angle side when you are finding the area of a triangle, okay? All right, so let's draw a picture of this triangle. It says that one angle is 61 degrees, and the sides that meet at this angle, so these 2 sides right here, have a length of 5 and 16 inches. Okay, so they gave me side angle side. So plug it in. So area equals 1/2 times each of the sides times the sine of 61 degrees. Okay, so I would clean this up a little bit more before taking it to the calculator. I can't take half of 5 because that's a decimal, but I can take half of 16, that's 8. And then 8 times 5 is 40. So 40 sine 61, and then I'll take that to the calculator. I'll use this one this time. So 61 sine times 40 equals Rounding to the nearest whole number, that would be 35. So 35 inches squared. So C was the correct answer. All right, number 6 says, which expression represents the arc length, arc length again, S of a 150-degree angle with radius R. So they gave me the radius, it's just the letter R. They gave me the angle theta, but it's in degrees. I need that to be in radians, so let's go ahead and convert that to radians. So times pi over 180, or you can remember what 150 degrees is from the unit circle. That would be 5 pi over 6, I believe. But let's try this. So if it's an angle on the unit circle, they're all divisible by either a 30, a 60, or a 45. But they also end in a 0, so they are also divisible by 10. So you just got to keep reducing it until you can't reduce anymore. I like to look for the biggest number. So 150 divided by 30. Does it go in evenly? Yes, it does. So 150 divided by 30 is 5. 180 divided by 30 is 6. So like I thought it is 5 pi over 6. But you could also remember that off the unit circle, okay? So arc length equals S equals theta times R. So S is going to equal, the theta is 5 pi over 6, and the radius, they just want us to use the letter R. So it's 5 pi over 6 times R. So the answer is C. Number 7 says, which of the following are equal to the sine of 240 degrees? So for this one, I'm just going to draw a quick little sketch of a unit circle, not a full complete unit circle, but a unit circle nonetheless. Let's see, here would be 180, so 240, because this is 270, 240 is over here. Okay, that is the same as 4 pi over 3. Okay, and we know that the coordinates here would be a negative 1/2 negative square root of 3 over 2. Okay, all right, so now that I know that, let's look at all the other pi over 3s. So we've got a pi over 3 up here. That's a 60-degree angle, but that would be 1/2 square root of 3 over 2. So these aren't exactly equivalent because these are both negative, these are both positive. We have a pi over 3 down here in the fourth quadrant. That would be 5 pi over 3. That's the same as 300 degrees. And the coordinate here would be 1/2 negative square root of 3 over 2. And then the other pi over 3 is this one up here. It is a 2 pi over 3. That's the same as 120 degrees, and the x is negative, the y is positive. Remember, cosine is x, sine is y, because all of these have signs in them. So let's look. Sine of pi over 3. So the y value at pi over 3 is the square root of 3 over 2. Is that the same as negative square root of 3 over 2? No. So that's not it. Sine of 2 pi over 3. Is the y value the same as this y value? No. This one's positive, this one's negative. So nope. Sine of 5 pi over 3. Is this y value the same as this y value? Yup. Check. Sine of 60. 60 degrees is up here. The y value is square root of 3 over 2. It is not the same as negative square root of 3 over 2, so it's not that one. Sine of 120, well, the y value there is the square root of 3 over 2. This one's negative, so nope. And sine of 300 degrees, well, the y value is negative square root of 3 over 2. This one is negative square root of 3 over 2, so that one matches up. So it was only those two options. You gotta know your unit circle. You're only going to get the first quadrant, regular math 3. Enhanced math 3 doesn't get any of it. They have to know their unit circle. All right, so that's number 7. Number 8 says a customer in a rotating restaurant is seated 40 feet from the center. How many feet does the customer travel after the restaurant rotates 5 pi over 12 radians? Okay, so I'm looking at the wrong one. There it is. There it is. Okay, sorry, looking at my review. All right, so first of all, if we've got a customer in a rotating restaurant and he's seated 40 feet from the center, they're talking about the center of a circle. So that 40 feet is the radius. The radius is 40 feet. And they're asking how many feet does the customer travel? So they're asking about arc length, okay? So this is another arc length question, and the restaurant is rotating 5 pi over 12 radians, so this is our theta. So they gave us theta, they gave us r, we need to find s. So remember, s equals theta times r. So theta is 5 pi over 12, and r is not 40 degrees, 40 feet. What am I thinking? 40 feet. R is 40 feet, so times 40. So all we have to do is type this into our calculator. So if you're using this one, you have to put 5 times pi equals, and then times that 40, because that's across the numerator, and that's your numerator. Divided by 12 times 1. Well, 12 times 1 is 12, so all I have to do is divide by 12 and hit equals, and this is approximately 52 feet to the nearest whole number, which means that this is B. All right, number 9 says the minute hand on a clock rotates 7 pi over 6 radians while Steve waits for an appointment. How many degrees does the minute hand rotate? All right, so we're converting 7 pi over 6 into degrees. So you can either remember that this is from your unit circle, or you can convert it by multiplying by 180 over pi. The pi's cancel. Let's see, we can reduce. 6 goes into 180, so 180 divided by 6 is 30. So 6 goes into itself once, goes into 180 30 times. I know 7 times 3 is 21, so 7 times 30 is 210 degrees. And there it is, letter C. Oops, wrong one. Number 10 says, which angle is coterminal with an angle of measure a negative 120 degrees? Okay. So coterminal angles, this is where we add 360 or subtract 360, or in this case, they want the angle in radians, so we're gonna need to convert it to radians. So let's go ahead and add 360, subtract 360, and see what we get, and then convert the positive one into radians, because obviously all of these are positives, so I don't want the negative coterminal angle, I want the positive coterminal angle. So if I add 360 to 120, that's what, 240? Negative 120 plus 360 is 240. So I need a 240 degree angle, so you can either remember this from the unit circle, or you can convert 240 degrees to radians by multiplying by pi over 180. Okay, all the angles from the unit circle are divisible by 30, 60, or 45, or 90. So let's see, that's a 240. Is that divisible by 60 or 30? It's divisible by 60. 240 divided by 60 is 4. 180 divided by 60 is 3. So this is the same as 4 pi over 3. So B. Okay. All right, number 11 says an angle theta is in standard position and intersects the unit circle at the point 1, 0. What do we know about the cosine of theta? So first of all, this is on the unit circle, and we've got a coordinate on the unit circle. Remember, the x is your cosine, the y is your sine. So that means that the cosine of theta is equal to 1. So cosine theta equals 1, it's got to be B. That was number 11. Number 12 says, what is the exact value of the tangent of 2 pi over 3? So this is the work I expect to see. I don't want a full unit circle, but I want a unit circle. Let's see, 2 pi over 3 would be up here. That's a 120-degree angle, and its coordinates are negative 1/2 square root of 3 over 2. So we have to remember that tangent is sine over cosine. And in a coordinate, cosine is x, sine is y. So to find the tangent, I need of theta, so I should put 2 pi over 3 in there. Tangent of 2 pi over 3 would be the sine, which is the square root of 3 over 2, divided by, I'm going to use the division symbol instead of a fraction bar, divided by negative 1/2, because I'm going to have to divide fractions, and they're easy as pie. You flip the second and multiply. So square root of 3 over 2, convert to multiplication by flipping the second fraction. The 2's are going to cancel, and I have square root of 3 times the negative, so that's a negative square root of 3. So that is my tangent of 2 pi over 3. So B is the correct answer. Okay. Number 13 says, given the sine of theta equals negative 3/5 and theta is in the 4th quadrant, enter a value to correctly complete the sentence. Enter the exact value. Do not use approximations for pi or for square roots. So basically no decimals. So let's see, I need to draw a picture. So this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So my angle is in that 4th quadrant, which means if I have my initial side, my terminal side ends up in quadrant 4 because it opens up and around counterclockwise. But I need to make a reference triangle with the nearest x-axis. Remember, theta is always the central angle connected to the origin. And sine is negative 3/5. So I've got the opposite over the hypotenuse. Remember, in a fraction, when it's negative, you always put the negative in the top. So the opposite side from theta is across from theta. That would be negative 3, and the hypotenuse is 5. Now you can either remember that this is a special right triangle, it's a Pythagorean triple, and that missing side is going to be a 4, or you can use Pythagorean theorem. We could call that A. So a squared plus b squared is equal to c squared. So a squared plus 9 equals 25. Subtract 9 from both sides. A squared equals 16. Square root both sides, a equals a 4. So it really does equal a 4 if you can remember a 3, 4, 5 special right triangle. And then you have to check the sign. Well, the x-axis on that side of the graph is positive, so it really is a positive 4. All right, we need to find the cosine. In SOHCAHTOA, cosine is the ka, the adjacent over the hypotenuse. Well, the side that's adjacent to theta is the side that we just found. It's a 4. Over the hypotenuse is a 5. So it's 4/5. And that was it. That's our answer. Okay. Number 14 says, which expressions are equivalent to the cotangent of theta? Select all that apply. So we need to know cotangent's identity. Cotangent is cosine over sine, but cotangent is also the reciprocal of tangent. So those are the two identities that we know about cotangent right off the bat. So right off the bat, cotangent is equivalent to 1 over tangent. I see that one. 1 over cosecant, that's sine. Well, that's not the same as cotangent, so that's not it. And then the rest of these we need to test out. So let's test out this one right here. Switch out the cosecant with 1 over sine, because that's its identity, times cotangent. We know we could switch it out for cosine over sine. Okay, so this becomes cosine of theta over sine squared theta. That's never going to be just a cotangent. It has a cotangent in it, but nothing cancels. It doesn't reduce. So that's not it. Okay, let's try the other one. So I'll put this one over here. So tangent times cosecant. Well, tangent we could switch out for sine over cosine. And cosecant we could switch out with 1 over sine. Oh, and hey, look, the sines cancel. And then I get 1 over cosine, but 1 over cosine is secant. Well, that's not the same as cotangent, so that didn't work. Okay, so let's try another one. Let's try the last one. So cosecant and cosine. Cosecant I could switch out for 1 over sine. Cosine we just keep as cosine. Oh, and then multiply across, and we'll get cosine in the top, because 1 times cosine is cosine. Sine times 1 is sine. Oh, cosine over sine is cotangent. So it was just that first one and the last one. See how much it helps when you highlight? And then the last question, which of the following statements are true for all values of theta? Select all that apply. So to show your work on a problem like this, you need your big kahunas. There's 3 of them, just like your last quiz. The first one, the main big kahuna, is sine squared plus cosine squared equals 1. To get the second big kahuna, you need to divide everything by sine squared. Remember from your quiz? Sine squared over sine squared is 1. Cosine squared over sine squared is cotangent squared. 1 over sine squared is cosecant squared. Okay, and then to get the third one, you have to go back to the main big kahuna and divide everything by cosine squared. Sine squared divided by cosine squared is tangent squared. Cosine squared divided by cosine squared is 1. 1 divided by cosine squared is secant squared. So those are our 3 big kahuna identities. Okay, because I noticed the first one there is 1 plus tangent squared. That's just like this one, tangent squared plus 1. It does equal secant squared, so that one's true. Okay, and do we have any other big kahunas? Nope. So now we need to look at these and see if they're true or not. So let's start with cosine theta plus cosine tangent squared theta and see if it will equal secant. So remember to keep cosines, but I'm going to switch out that tangent for sine squared over cosine squared because that's its identity. And then I notice here that a cosine is going to cancel, but only one of them because that one's a squared and that one is not. So that goes down to 1. Okay, so now I've got cosine theta plus sine squared theta over cosine theta. Make that cosine a fraction because we're adding, so we have to get a common denominator. Needs to be a cosine, so I got to multiply it bottom and top because whatever we do to the bottom, got to do to the top. Cosine times cosine is cosine squared. All right, so my common denominator is cosine. When I add these, I'm going to have cosine squared plus sine squared. Well, sine squared plus cosine squared equals 1. So I could switch that out for a 1, and 1 over cosine does equal secant theta. So this one is true, so I could check mark it. Okay. For the next one, cotangent theta minus 1, I need to see if it's going to equal cosecant. So let's switch out that cotangent. It's cosine over sine minus 1. Okay, well, let's make that minus 1 a fraction by putting it over 1. We're subtracting fractions. We need to get a common denominator. So I'm going to need to multiply top and bottom by sine theta. And I'm going to get the common denominator, sine theta. In the numerator, it's just going to be cosine theta minus the sine of theta. Yeah, that's never going to equal this, so that one's done. Okay, all right, and then let's do the next one. So I'm going to switch out the cotangent squared theta, and we need to see if this equals secant theta. So sine theta times cosine squared over sine squared, because the cotangent is squared, plus sine theta. And make that a fraction, and I see that one of those signs is going to cancel, just one of them, and so I will have cosine squared over sine plus sine Put that over 1. Need to get a common denominator, so we got to multiply bottom and top by sine. In the top, sine times sine is sine squared. So I'm going to have the common denominator is sine, and cosine squared plus sine squared is the big kahuna equals 1. 1 over sine is cosecant of theta. Oh, it doesn't equal secant, it equals cosecant. So that's wrong. And then the last one, oh, I'm running out of room. I'm going to try to squeeze it in this little space right here. Okay, so I need cosine theta plus, keep the sine. I'm going to switch out that tangent. So that would be sine over cosine. And we need to see if that equals secant theta. Nothing cancels, so let's just rewrite this. We'll have cosine theta, make it a fraction over 1, plus sine times sine is sine squared over cosine. We need to get a common denominator. It needs to be a cosine, so multiply by cosine top and bottom, and we'll get that cosine squared in the top. So cosine squared plus sine squared is 1, and our denominator is cosine, and 1 over cosine is secant. So that one works. So that one had 3 correct answers. The first one, the second one, and the last one. And that's it. Have a good one, you guys.